This is lesson 2.9, solving one-step inequalities by adding and subtracting. Solving inequalities by adding and subtracting is just like solving equations. We want to isolate the variable. We want it all by itself, hopefully on the left-hand side, so that we can see what it's either less than or greater than. It doesn't matter now that we're not dealing with an equal sign. It's still exactly the same. Your goal is the same. You must isolate the variable. So when you have an inequality that involves addition, you have to subtract to solve. Because we want that variable by itself, you have to remove that number from the variable side. You have to undo the addition that's there. The book talks about the subtraction property of inequalities, and this is what it says. If A is greater than B, then A minus C is greater than B minus C. In other words, if you have an inequality, when you subtract the same thing from both sides, that inequality remains the same. The same way our equation stayed balanced when we did the same thing to both sides. For example, if x plus 5 is greater than 4, then x plus 5 minus 5 is greater than 4 minus 5. I'm subtracting the same number from both sides, so the inequality remains the same. When we remove the 5's, we get x is greater than negative 1. You see that sign, the greater than sign, is the same as it was in the original problem. The sign does not change. If A is less than B, then A minus C is still less than B minus C. When you subtract, the inequality remains the same. As long as you're doing the same thing to both sides, the inequality will remain true. So for example, if x plus 3 is less than 6, then if I subtract 3 from both sides, I get x is less than 3. Try to solve these. We'll start with this one. N plus 8 is greater than or equal to 19. The property we talked about before holds with a greater than or equal to and a less than or equal to, as well as a greater than and less than sign. To solve for n, you have to subtract 8 from each side. But doing this will not change the inequality. So let's see what happens. When you do that, you get x is greater than 11. I subtracted 8 from both sides. Now to graph it, we're going to draw a number line, and we're going to plot 11. I ask that on your number lines you have at least 2 numbers so I can have some reference as to where 0 is. Since n is greater than or equal to 11, there must be a solid circle on 11, and the arrow will go to the right. So here's our graph. Let me pull up a marker here. So we're going to put a solid circle on 11, solid. And the arrow must go to the right because n is greater than or equal to 11. That means 11 is included in the answer set. 11 will work in the inequality. And that's why we draw the solid circle. Sorry about that, my arrow is a little slow. Okay, so let's continue with the next example. Now we have negative 26 is greater than y plus 14. To solve this one, you need to subtract 14 from both sides. And when you do this, you get negative 40 is greater than y. You see that sign didn't change. It's still greater than, right? But to understand the inequality, it's easier to turn it around, to reverse it, because we'd like to have the variables on the other side. So to turn it around, you would actually read it from right to left. And when you see that, you see y is less than negative 40. So I've rewritten that as y is less than negative 40. Now let's think about graphing this. Graphing this, we want negative 40 on the number line, but we want to go to the left of negative 40 because y is less than negative 40. Because this is a plain less than sign and not a less than or equals to, it will be an open circle on negative 40. So let's do that. Okay. So this is going to be negative 40 right here. And what I'm going to do, we'll change colors here. I'm going to draw an open circle on negative 40, and it's going to be less than negative 40, so we're going to go this way. Whenever there's an equal sign involved in an inequality, it's a solid circle on your point, and whenever it's a greater than or less than sign, it's an open circle. Let's take a look at a word problem. Here it is. Nearly 768 megabytes of memory are available from running your computer. If the basic system requires 512 megabytes, how much is left for other programs? And here you can assume your program will not run properly if every single megabyte is used. So what you have left has to be less than the 768. So first we always define our variable for the word problem. What do you want to know in this problem? You want to know how much is left for other programs. So we're going to let M equal the memory for the other programs. Now your basic system requires 512. So 512 plus the M, the memory for the other programs, must be less than 768. To solve this, you'd subtract 512 from each side. So you get 512 plus M minus 512 is less than 768 minus 512. M must be less than 256 millibytes. So your usage has to be less than that for your computer to run correctly. If your usage is over that at all, your computer will not run. Let's try another one. An airline lets you check 65 pounds of luggage, and one suitcase weighs 37 pounds. How much can another suitcase weigh? Well, again, what do we want to know? We want to know how much the other suitcase can weigh. So let's let S equal the weight of the other suitcase. Then, when we set up our problem, the 37 pounds that you know, plus the S, the weight you don't know, it has to be less than or equal to 65. Because 65 pounds is allowed, so you can be equal to that. We'd like to be less than that if we can. So it's less than or equal to 65. To solve this, I subtracted 37 from both sides. So I get S is less than or equal to 28. When an inequality has subtraction in it all, though, you have to solve it by using addition. See, we're using the opposite kind of operations. We're undoing the operations that are there. Just like subtraction, you can add the same number to each side and you don't change the inequality at all. So the property says if A is greater than B, then A plus C is greater than B plus C. If you have an inequality and you add a number to it, it is not going to change the inequality. And it doesn't matter whether that inequality is a greater than or a less than inequality. It will not change. It will stay true as long as you're adding the same number to both sides. So for example, when you have a problem like n minus 15 is less than 3, to solve for n, we want to isolate it. We need to get rid of that negative 15, so we're going to add 15 to both sides. And when we do that, we get n is less than 18. Again, the sign does not change when you're adding to both sides. In the next example, m minus 13 is greater than 29. We're adding 13 to both sides to eliminate the negative 13. When you do that, you get m is greater than 42.